Fraud intelligence analysis, also known as FIA, is a key part of IBM's overall fraud, waste, and abuse capability. We'll take a brief look at a scenario which demonstrates detecting, investigating, and managing a financial services scheme. Our story begins when a field investigator named Chris receives a report from a customer regarding some unauthorized charges and withdrawals on his credit card. Chris logs into the collaborative analysis repository through a secure web portal to see what he can find out. He was told the reporting party's name is Bob Hirsch, so he conducts a very simple search. Thanks to the fuzzy search logic, which takes into account things such as common name variations and human errors and typos, the tools were able to locate the most likely match in the repository, named Robert Hirsch, spelled slightly differently. From within the web portal, Chris is able to get a quick visual and verifies Mr. Hirsch's report. He sees that there have been a few purchases on Mr. Hirsch's credit card. He also sees the disputed charge that was reported by Mr. Hirsch. As he expands on the visualization, he also sees that there were several other disputed charges associated with a convenience store ATM. This is highly suspicious, so at this point he decides to forward the case to an analyst at corporate headquarters to take a deeper look. Tracy, the analyst to whom the case was assigned, accesses that same collaborative repository that Chris was working in. However, because she needs the ability to take a very deep dive into the data and conduct a thorough link analysis, she explores it through the charting tool, directly through her desktop. Now she decides to take a very targeted approach and search specifically for disputed transactions that fell within the week in question. She first filters by the link type, looking only for transactions associated with a dispute. She then narrows the field even further to specify only the week in question. She receives a very specific answer to that very specific query that she made. She has the ability to scroll through and look at the details of each individual transaction. But instead, she chooses to add all of the results to the chart to start visualizing. She has cast a very wide net and sees that all of the disputed transactions are associated with the same ATM. At this point, she decides to expand out on this ATM in question to find its location. Instead of casting that wide net and bringing in a lot of information, chooses to pull a specific investigative thread. As she expands out on only this suspect ATM, she finds that there are actually three, all of which happen to be located in Las Vegas. Now, the original reporting customer lives in another state, and that has been confirmed, that he has not been in Las Vegas. So Tracy knows that something is wrong, and she decides to look into other transactions that are associated with the affected accounts. Thanks to features such as filters and histograms, we're able to select only the pieces that exist on this chart that we're interested in at that particular moment. And this time we're going to go after our data from a different angle and look only for the transactions associated with these specific affected accounts. We've pulled in a lot of information, and there's far too much information on this chart, in this case over 500 entities, for Tracy to make sense of visually. So she chooses to use some of the built-in analysis tools to find only the most important relationships and interconnections. You can see here are a couple of the affected accounts, as well as some of the locations where those cards have been used. Now, one of the powerful analysis tools that she chooses to use in this case to start making sense of all the information is called Find Matching Entities. This has a bit of a fuzzy search technology built in as well. It will find entities that are similar but not exactly the same, such as Dominic Scaletta and Scaletta Dominic. Now, one thing that is interesting is that she sees that there were several Michael's department stores. And so she chooses to select all of these and see what she can find out. And she decides to go back and see if there were any additional common denominators that existed within this data. The only thing that she finds is additional Michael stores. So this is a good investigative path, and she feels good about where this analysis is going. So she decides to contact one of her fellow analysts that work at that retailer to see if there are any additional information to be had. Now, because I2 tools are often a common language between investigators, whether it be in law enforcement or corporate investigators on the private side, it is absolutely possible to collaborate outside of your own organization. So Tracy contacts her fellow analyst at the retailer, and she provides those affected store numbers. So we're able to simply provide the store numbers to the other investigator, who can then look into her own analytical repository to find any interconnections. Now, this analyst wants to cast a very wide net, knowing that this is a time-sensitive issue. So they're casting a wide net within her own repository to see if any relationships exist, specifically between these stores. So that investigator chooses to do a full expand. And as I reapply different layouts, as you see, the visual changes because different visuals work better for different people. However, the information on the chart is not changing in any way. Now, in this case, we have a lot of new information that's been added to this chart. But again, this analyst wants to quickly figure out where she should direct her attention. So she decides to use a powerful analysis tool called social network analysis. Now, social network analysis is not referring to things like Facebook and Twitter, but instead is referring to a series of centrality measures that are based on algorithms built into the back end of the chart. It looks at the relationships that exist within networks of entities. So it is not specific just to people, but to any person, place, or thing that you might be dealing with, such as accounts, card numbers, store locations, etc. So you can choose any one of these up to all 4. And then we ask the tool to simply calculate these results for us. As we expand out and look at these results, they are stack ranked in ascending or descending order, whatever you choose. And one thing that I noticed very quickly, aside from the fact that the entities or the results are broken out by entity type, is that when I look specifically at the people, regardless of my score, this person, Thomas Nevers, keeps rising to the top. So we can step in and look at some of his history, again back in that collaborative analysis repository, because he does appear to be the only common denominator between all 12 affected stores. As we look at Mr. Nevers' record information, we can see a lot of information on him, including the fact that he did start with the retailer back in November of 2011, working in the women's department at the Tempe department store. But I also see that there's some additional information about him, highlighted on a second card. As I explore this path, I see that in March of 2012, he actually transferred into the IT department, and this ended up giving him access to all of the retailer's systems. So as we go back to the chart, we feel comfortable that we've identified a likely suspect. So the 2 analysts would like to combine forces, and this is as simple as copying and pasting all of the information on one chart onto all of the information on another chart. So we're going to simply select all and copy. And this is as easy as sharing any other type of document. So as we paste this new information, we'll again reapply a layout to see any of the new information and interconnections that have been discovered. We see a new cluster down here, and that does include Mr. Nevers. So we've been able to let the tools do a lot of work for us by automatically finding any common relationships that exist between the 2 separate investigative charts. Now, as a final measure to confirm their conclusion, they decide to apply yet another analytical tool and some other measures known as filters and histograms, as we mentioned earlier. And this will allow us to see the full effect of the scheme and to find any patterns and trends that might exist within our data. So we choose to look at any patterns and trends by date and time. By looking at the information as a histogram, it opens up our common bar chart on the bottom of the screen. And so we can easily see some of the peaks and valleys, and we see that there are some definite spikes in information and activity. Specifically here on 313, which, if you remember, that is the point that Mr. Nevers transferred into the IT department. We also see a spike in the last week of March, and we know that that is the time that a lot of those disputed transactions occurred. Notice again that as we select through these different areas, the other pieces that we're not particularly interested in at that point are grayed out to allow us to really focus in just on the affected pieces. Now, the other interesting thing about filters and histograms is that utilizing the histogram feature opens up an additional layer of analysis known as a heat matrix. So it gives us an additional view. In this case, we can look at the transaction amounts associated with this scheme. And when we change up the color, we very quickly get a heat map. So we can quickly focus in on some of those areas of higher activity. So now they feel comfortable where their analysis has taken them and that they have figured out this scheme and who their most likely suspect is. So at this point, they create a final presentation chart so that they're able to present to other investigators as well as to law enforcement for prosecution. Now, knowing that handing a large chart such as this can be overwhelming to a person, so they choose to apply some of our additional features, such as conditional formatting. And this can help to weed out some of that extra noise, such as some of these individual transactions and other store locations where the cards were used that were not affected in this particular scheme. One of these key formats would be hiding entities that only have one link. Again, this is going to filter out some of that noise. So it immediately grays them out, but we can fully remove them from the chart and then reapply a layout to bring this final chart together. Again, different layouts work better for different people, so it's good to try out different ones and see which visual that you like best to present to law enforcement. Presenting this final presentation chart to law enforcement, ultimately, Mr. Nevers was interviewed by police, and he confessed to installing skimming devices at all of the stores, which he then used to create duplicate cards and to withdraw funds from the victims' accounts. Without tools such as fraud intelligence analysis, the far-reaching effects of this crime may have never been discovered nor prosecuted.
If you liked today's video, please click on the like button and subscribe to this channel.